So, good day everyone. We are the group number 3 and we will present our experiment frequency shift keying or FSK modulator and demodulator. And I'm Wilson Numeres, the first presenter. What is FSK? Frequency shift keying FSK or FSK is a type of frequency modulation which represent the binary data in the form of variation in the frequency of a carrier signal. So yung FSK po, kamukha po ng FM. Pero two-state lang po yung frequency ng carrier. Yung space and mark frequency, yung space yung mas mababa yung frequency. Then FSK transmitter as well as FSK receiver implementation are simple for low data rate application. So pag yung data plate po na ginamit ay mababa, magiging simple lang yung pag-construct ng circuit para sa FSK modulator and demodulator. Yung experiment po, low data plate yung ginamit. And most early telephone line modems use audio frequency shift keying or AFSK to send and receive data at rates up to about 1,200 bits per second. The Bell 103 and Bell 202 modems use this technique. It has higher immunity to noise due to a constant envelope. Hence, it is robust against variation in attenuation through a channel. Dahil po constant yung amplitude, less susceptible po yung FSK sa noise. Then, the simplest and most common form of FSK uses a pair of discrete frequencies to transmit binary zeros and ones information. With this scheme, the 1 is called the mark frequency and the 0 is called the space frequency. Yung pinaka-simple po na FSK ay ginamit ng dalawang carrier na magkaiba ang frequency. Isa sa dalawang frequency ang magagamit na nakadepende sa binary signal. Pag logic 1, mark frequency ang gagamitin. Pag logic 0, space frequency. Then, this type of modulation is called binary FSK, BFSK. And it's used for communication systems such as telemetry, weather balloon, radio sounds, caller ID, garage doors openers, and low-frequency radio transmission in the VLF and ELF bands. This experiment uses a BFSK as a modulator scheme to produce FSK signal. So, binary FSK po yung tawag sa scheme po na ito. Yung BFSK po ginamit sa low frequency transmission. Then next is the setup of the experiment. The following components are used in this experiment. Transistor 2N4921 and 2N4920, 1 piece each. Then resistor 15K, 10K, 1K, and 10K, 10K pot, 1 piece, 5 pieces, 3 pieces, 1 piece respectively each. Then the capacitor is 0.1 microfarad and 100 nanofarad, 1 piece each. Then diode IN4001, 1 piece. Then Zener diode 5Z1, 1 piece. Then operational amplifier IC741, 2 pieces. Then signal generator, 3 pieces. Then oscilloscope, CRO, 3 pieces. Then last power supply, positive, negative, 15 volts, 500 millivolts, 1 piece. Then the next FSK modulator circuit will be presented by Kirby De Guzman.
Good day, I'm Kirby De Guzman and I will report FSK modulator circuit. The FSK modulator circuit used in this experiment is set up in the following manner. Ayan po yung circuit ng FSK modulator circuit. The FSK modulator used in this experiment is just a simple circuit consisting of two transistors. The transistors function as a switch for two carriers with different frequencies, 1 kHz and 2 kHz. Switch lang yung dalawang transistor na may 1 kHz at 2 kHz. When the input binary signal is high, the NPN transistor conducts, and the PNP transistor will act as an open switch. When the input binary signal is low, the NPN transistor will become open, and the PNP transistor will be shorted. Pag high yung input binary, yung NPN magiging close. Yung PNP will be open. Pag low yung input binary, yung NPN magiging open, yung PNP magiging close. When the NPN transistor is conducting, the 1 kHz or space frequency carrier signal will be connected directly to the ground, while the open PNP transistor will be open, and the 2 kHz or marked frequency carrier signal will be amplified by an op-amp with gain of -10. Pag input high yung 2 kHz na carrier, magiging input sa comparator. Yung 1 kHz magiging shorted. Yung input carrier frequency ma-amplify ng op-amp. Yung gain ng op-amp is -10. Next slide. The FSK modulator outputs of the following signal. Ganyan yung output ng modulated FSK. The signal produced is binary frequency shift keying signal. Below is the circuit of the modulated FSK. And that will be the result. Yung signal na may marked frequency, yung lilitaw na output. Pag yung input binary is high. Pag low naman, yung space frequency, yung lilitaw. This is the simplest analog form of FSK. Kaya nasabing ito yung pinakasimpleng form ng analog form ng FSK. Yung ginagawa ng BFSK ay pumipili lang sa dalawang frequency depende sa input binary signal. And that's the FSK modulator circuit. The next reporter will be Jester Dale David and will report FSK the modulator circuit.
Good day everyone, I am Jester Dale David and I will present FSK demodulator circuit. So the FSK demodulator circuit is the following. The demodulator consists of a resistor and a capacitor that acts as a low-pass filter, a diode or a rectifier, an envelope detector which consists of a capacitor and a resistor in parallel, then a comparator to output a digital signal, and two Zener diodes for to limit the amplitude of the digital output to match the original message. So the demodulator circuit works. First, the signal that is the 2 kHz signal is being attenuated by the low pass filter. So whenever the FSK is in the marked frequency, that signal will be attenuated. But when it is in the space frequency, it will pass this filter, then it will be rectified by the diode, and then the envelope detector will be inputted to the comparator, which will then compare it to a reference signal, which you can adjust using a potentiometer to uh, to get the demodulated signal. So the output of this demodulator circuit will be shown in the following. So this is the output of the demodulator circuit. Uh, Here, as you can see, the demodulated signal is not that exactly the same compared to the original binary. There is a wrap up when the moment the input signal becomes high. There is a wrap up, and there's an it that is caused by uh, because the mark frequency and space frequency are not that far away from each other. So when the low pass filter will not effectively attenuate the high frequency, the mark frequency. So it still has a ramp up effect when the input signal is changing. The low pass then this ramp up can be cleaned by the use of capacitor as a filter on the output side of the demodulator signal. So this is the comparison of the original signal against the demodulated signal. Here you can see that the moment that the binary signal becomes high, the demodulated signal doesn't immediately go high, but there is a wrap up time. But you can straighten this ramp up time by the use of the capacitor filter on the output side of the demodulated signal. So the conclusion of our experiment is that FSK modulation is a modulating technique that changes the frequency of the carrier frequency in accordance to the input binary signal, much like a FM technique. Then FSK modulation and demodulation can be constructed easily. We saw in this experiment that the modulator is just two transistors that acts as a switch to output either the space and the mark frequency, which depending on the input binary signal. And while the demodulation uses only a low pass filter, a envelope detector, a comparator, and a Zener diode voltage limiter. And the FSK modulation is less susceptible to noise because it relies on the amplitude of the carrier signal. And next, it uses a larger bandwidth compared to the other modulation techniques like ASK and PSK. Hence, it is not bandwidth efficient. Since the FSK uses many different frequencies of the carrier signal, it occupies a larger bandwidth. When in the telecommunication media, the telephone lines have very low bandwidth. It is not possible to satisfy the bandwidth requirement of FSK at a too much higher speed. So in a method of FSK is preferred only for the low speed problem. And that's it for our experiment, and thank you very much. And this is the timeline of experiment.